Well, hello, calculus students and general pre-calculus students, I should say, and general seekers of truth. Welcome to our video lesson here on properties of logarithms. And I will start you off quite quickly here with what I call the product rule of logs. I'm going over this kind of quick because I think you've learned this in Algebra 2 already. And this should be product rule, excuse me. There's not multiple product rules of logarithms. And yeah, I think you may have covered this already in a previous class, and I will also prove it for you. But this rule says that if you have log base b of x plus log base b of y, then thus this must be equal to log base b of x times y. So as long as the bases of these logarithms are the same, then you can combine the addition of two logarithms. And we won't prove this for everything, but we are going to prove it for this particular case. Okay, so I will draw a line here, and let me do a nice proof of this, just so that you get a sense of where we're going with this, and this is not just something completely weird and random. So proof of the product rule, and I'm going to define quite a few variables here. So let log base b of x equal some number, some value, let's call it big R, and log base b of y be equal to some other number, let's call it s. Okay. Now, if we convert this to exponential form, then what we have here is base b to the rth power is equal to x, and base b to the sth power is equal to y. So if we continue with this route, then we know that x times y must be equal to the stuff on the left side here, b to the r multiplied by b to the s. Now we can apply our basic rule of exponents when we have the same base and different exponents. Then we can add those two exponents together. So this is b to the r plus s. Then I'm going to convert back, and I'll make a note here. We're going to convert back to logarithmic form. Well, when I do that, we take the log base b, right, that's log base b of x times y, and that must be equal to r plus s. Okay. But lo and behold, what was r plus s to begin with? Well, look over here. R was log base b of x, and s was log base b of y. So this is really log base b of x plus log base b of y. And this completes the proof of the product rule. So, and there's quite a few other rules, but we're not going to prove them all. I am going to continue here. We have an analogous situation, what's called the quotient rule of logarithms, and it basically says the reverse or the inverse of this, that if you have log base b of x minus log base b of y, then not surprisingly this is equal to log base b of x divided by y. So if you add two different logs, then you get the log of the product. If you subtract two different logs, then you get the log of the quotient. And finally, there's one more that we're going to use here in this video, and it is known as the power rule. So the power rule says that if you have log base b of x to the nth, then we can bring this n down to the front. This would be n log base b of x. So I'm not going to prove everything here in this video. The proofs for the quotient rule and the power rule are very similar to this proof. You set up two known equations, and then you manipulate the properties of exponents, and then you convert it back to logarithms. Okay, so I welcome you to prove this for yourselves as an exercise. I'm going to end this video here. I'm going to start another one where we apply these rules. Thank you for watching and have a wonderful